Hello, my name's Sean Walbridge. I'm a senior systems engineer with Cumulo. We do NAS software. So I'm going to talk through how to optimize ED and M&E workflows with hybrid cloud and global namespace. My background is visual effects. I was in the industry for 20 years before coming to Cumulo, longtime customer. So I'm kind of going to step through some of the things that I went through and how some of the things that Cumulo is doing now will help our customers. So this is how a lot of visual effects companies start. One guy working in his garage, he's got an external drive, then they add another person, and they get another external drive, and they add more people, and then they get a consumer NAS. They're working on projects. Then they get bigger, get more projects. Then they move to a small office and get some render nodes and some more small NAS appliances. Then they keep getting bigger, more render nodes, more storage, and then they move into an office, more render nodes. They're getting more projects. They're doing 4K now, so they move to so then they buy a enterprise grade storage, and then they keep getting bigger and bigger. They start to render in the cloud, and then COVID happens, and everybody moves to remote work. They're working from their house. But now the company's paying for this big building. They've got all their infrastructure on-prem, and people start to move away. They don't want to live near the studio, better cost of living, better quality of life. And then it becomes global, and people are remoting into workstations, and it doesn't really scale because when you're using remote software, typically you have 90 milliseconds above that. The latency is too high, and the artist can't work. But you have that access to that global talent pool around the world, and you want to help them. You want to utilize those artists, but how do you solve that? So people think, okay, I'm going to move to the cloud because the cloud runs everywhere. But the problem is that the cloud can cost a lot of money, and this is where Cumulo comes in. Today we announced our new cloud-native Cumulo that runs in AWS. It's the same architecture that we've been running in Azure for quite a while now, and then we also run in Google GCP as well. So we provide cost-effective storage, high-performance storage in all three major hyperscalers, as well as on-prem. The Azure native Cumulo, which these slides were submitted yesterday, so this is our cloud-native version of Cumulo that runs in Azure. But today we announced that it's now available in private availability in AWS. So the good thing about the new version of Cumulo in the cloud is that you have elastic performance segregated from the capacity. So you can increase your performance without necessarily adding any additional capacity, but you can also turn down that performance when you don't need that capacity. We've moved to using object store or blob on the back end, so we can get that cost effectiveness of using object, but have full file system access with NFS and SMB. So this slide shows that we can scale performance independent of capacity, so you can have and you can scale up and down elastically as your use case, as your performance needs increase or decrease. If you delete data, you just pay for what you use, so it's based on used capacity, not provisioned capacity. And because of that change in architecture to move to object storage on the back end, we can do it for substantially less cost than any of our competitors. We have a hot tier and a cold tier. The cold tier starts at $10 per terabyte per month. The performance tier starts at $37 a terabyte per month and will drop down to $30 once you hit a petabyte. Compared to our other competitors, very big cost savings. you're able to, with Cumulo in cloud native Cumulo, we can scale performance from 1 gigabyte per second to up to 100 gigabytes per second or more, with no need to redeploy or migrate your data. We can just do it on demand. Once we go up to 4 gigabytes by default, above that, we just need 15 minutes notice to add more infrastructure behind it. So we can hit 100 gigabytes per second in 15 minutes with 15 minutes of notice. And you only pay for the performance that you actually use. So by default, you get 1 gigabyte per second, and then we bill based on per gigabyte per second above that. So unlike on-prem or typical cloud storage solutions where you have to buy pre-provisioned capacity and performance to meet your demands at peak, with cloud native Cumulo, you can actually just deploy and this performance will scale as you need it, both for capacity and performance. And it's pay as you go, so you don't have to make a long-term commitment to run in Azure or AWS. And then another feature that we announced today is our global namespace. That allows you to tie together multiple Cumulo instances running on-prem or in the cloud or at the edge and allow clients to access data on your remote clusters. So that allows you to increase your agility, move the data when it needs to move, and just really changes the way you look at file these days. So some of our use cases are you've got a hub with the majority of your data, whether it's on-prem or in the cloud, and then you've got spokes of clusters where you have connections to your main hub, and they have full access to the file system. We'll do preemptive caching. Our caching algorithm has been designed over the last 10 years and tuned in our hybrid nodes. So we can, based on 4K blocks, we've got a 4K heat map of the data that's on the cluster and being accessed, and we'll pre-fetch that to the remote cluster. We can actually measure the latency between the two clusters and preemptively fetch the data that's on the remote cluster based on expected use case usage from the local clients. And there's no file system locking issues because we use our file system API to talk from one cluster to the other to do file locks on the hub cluster where the data home is living. So this is an example of how it works with the read path. So we've got an archive folder on the hub shared out to the spoke, has access to it. And then the metadata is instantly cached as soon as the portal is created on the spoke. And then as data gets requested, we'll pull it over and store it on that spoke cluster near the clients. And then as the cache starts to fill up, what we'll do is we'll actually prune that cache once it gets to a certain point, and we'll delete data that's least recently used. So another use case is where you've got multiple offices sharing data. You can actually have a hub and spoke. You can have a cluster be both a hub and a spoke. So you can actually have your on-prem cluster in one location and another cluster in a different location, and they can share data between the two of them. So if you've got a project that starts in one location and moves to the other, you'll be able to move that data. But it just allows you to to have the work happen where you need it to happen instead of where the data is. And then you've got the idea of the geo-distributed collaboration, where you've got maybe a central set of data, either on-prem or in the cloud, and then you use smaller clusters to just do caching at the spokes. So if you've got like a 6 petabyte cluster in the cloud or an on-prem, you can then have the spokes be smaller all-flash clusters, so you get the benefit of all-flash, but you've got the bigger data set behind it. The other one is just to tier data off to a colder storage and still have it accessible to the on-prem cluster. So if you've got an on-prem cluster and you need to archive data, instead of storing it on the local cluster, you can actually just move it off to the cold tier, and it's still accessible to all the artists as if it was on-prem. So, and as that stuff fills up on the on-prem, it'll tier off to the colder tier. And then the last part that we're working on right now is the moving away from it being an appliance where you buy a 4-node cluster with our certified hardware platforms, and moving to the ability to run Cumulo on whatever appliance or whatever devices you want that meet the performance requirements that we have. So installing it via a Debian package or an RPM. We just need to make sure that the performance of the machine that you're installing on meets the minimum requirements to deliver the performance that you're expecting. And that was very quick. Sorry. And we're having a happy hour here tomorrow night.